This kit is a wireless notice board. So here we have two sections. One is the transmitter section. This is the transmitter section. Here we have a USB port, USB drive, which is attached to a laptop from where we need to send any message, which has to be displayed on a notice board. And then the message is read by the USB drive. It comes to the microcontroller, and then this is an RF transmitter which transmits the message to the decoded or encoded message to the receiver. The receiver receives it, and then there's a decoder which decodes it and then displays it on the microcontroller. So I'll just show you a demo. So right now the screen is blank. So if you type anything on the software, you can see that it is, you are able to read it on the particular LCD screen, and then by pressing the concerned keys as mentioned in the manual, you will be able to clear it and then retype any message. So this is how the kit works. You can order this kit from our site kitscrew.com, where you'll get two versions of the kit. One is where you'll get this complete ready-made kit, which you can see here, and the other one is where you'll get all the components separately, and with the help of our video tutorials you'll be able to complete them by yourself. In this section of the video we'll see what all components are used in this kit and how to assemble those components on the PCB, how this kit works, and then how do we check the power supply. So first we'll discuss how this PCB works. So this is the transmitter section. As you can see, there's an RF transmitter here. So we have given a power supply through an adapter of 12 volts. So this is a power jack. This is the on-off switch. And this is a bridge rectifier. In case you're giving input through a transformer, you need to convert the AC input into DC output. For that we use this bridge rectifier, and then a capacitor which removes all the repulses which are produced during the rectification process. All the components in both the kits work on 5 volts, so we need a voltage regulator IC 7805 to convert the entire power supply to 5 volts. Then this is the main microcontroller. So this is the USB drive which receives the input from here, and then the microcontroller receives it and then sends it, detects it, and sends the data through the RF transmitter to the other kit. The receiver receives it and then sends it to the microcontroller, and then this displays the particular data here on this LCD screen. And then this is a crystal oscillator which gives the clock pulse to the microcontroller, and the other two ceramic capacitor to start the oscillation process. This is a reset button which resets the microcontroller, and a resistor of 10K to pull up the reset button. This is the power indicator LED, and this is the LED for the signal. That is a signal interface between the transmitter and receiver. This is a buzzer. As you can see here, this is a buzzer this is a positive terminal of the buzzer on the other side. And then this is a receiver kit. The components are almost similar. The only thing is we have an LCD here for the output. Like this is the USB drive for the input. The same way, this is the LCD for the output. So this is how the entire kit works. So now we'll understand how to assemble the kits on the PCB. This is the transmitter PCB. And this is the top side, this is the bottom side. We insert all the components from the top side and solder them on the bottom side. The technology that we use is called a through-hole technology, in which we insert components from the top and solder them at the bottom. So we have this ready-made kit here with reference to which I'll keep this particular PCB in line with this ready-made PCB so that we can understand the alignment of each and every component. Starting with the power supply, we'll insert the power jack. Then an on-off switch to control the power supply to the kit. Then a bridge rectifier. Bridge rectifier has 4 terminals, 2 AC input and 2 DC output terminal. This is the longest stem is the positive terminal, so that has to be present on the top right side. So this is where the alignment has to be taken care of. So the positive terminal is on the top right side. Then to remove the repulses which were produced during the rectification process, we insert this electrolytic capacitor. Even this has polarity. The stem which is longer in length is a positive terminal, and in case both the stems are of equal length, there is a strip on the capacitor which indicates that is a negative terminal. While inserting the capacitor, we need to ensure that we are facing the negative terminal of the capacitor. And then a voltage regulator IC. So this is the voltage regulator IC. The first stem from the left is the input stem, then center one is a common, and then the third stem on the right is the 5 volt output stem. While inserting, we have to ensure that we are facing the third stem, as you can see here. So another LED, which is a power indicator LED. So LED has 2 terminals. The stem which is longer in length is a positive terminal. In case both the stems are of equal length, the LED bulb is round in shape, but at the negative terminal it gets flat. So while inserting the LED, we have to ensure that we are facing the negative terminal of the LED. And we provide a resistor of 1K with color code brown, black and red in order to protect the LED. So this completes the section of the power supply. Then before inserting the IC, we'll use a jumper wire here. A jumper wire is used when the connection is not possible from the bottom side, so we put connections from the top side. So this is a 28 pin IC, and this is the IC base. This is the IC. So as you can see, there's a notch on the top of the IC. So the pin which is on the top left side of the IC is a pin number 1, and then you need to count the number of pins counterclockwise. So pin on the top right side is a pin number 28. So we use an IC base in order to protect the IC during the soldering process, and in case you need to replace the IC in the future, you can do that. So while inserting the IC base and the IC, we have to ensure that the notch is on the top side, as you can see here. Then this works on a clock frequency, so we insert a 16 megahertz crystal oscillator. And 2 capacitors of 33 picofarad in parallel. And then a micro switch is used to reset the microcontroller. And to pull up the micro switch, we use a resistor of 10K with color code brown, black and orange. Then another capacitor of 0.1 microfarad is inserted here. And then we'll insert this transmitter. So a transmitter has 4 terminals. So as you can see, this is an antenna wire. So the antenna terminal has to be closest to the antenna wire. So as you can see, this is the antenna terminal on the right side. So that has to be present. The antenna terminal has to be present near the antenna wire. So this is any normal wire that you can connect. And another LED to indicate the signal interface, the signal interchange, and along with that resistor. Of 1K, and then a buzzer. So the stem which is longer in length is a positive terminal, so that has to be present near the microcontroller, the positive terminal. And then a 4-pin base has to be connected here, so that can be inserted with the help of a bud strip. So the 4-pin base will be connected here, and this USB has to be connected to that. So while connecting, we have to ensure, while connecting the USB drive, as you can see, there are a number of terminals here, ground, RX, TX, and then the 5 volts VCC. So while connecting, we have to ensure that this is the VCC, then ground, and VCC, ground, TX, RX. So the TX on this particular USB drive has to be connected to the RX here, and then the RX has to be connected to TS, then ground, and then VCC. So this is how the connections has to be done for the USB drive. So once you have finished assembling the components on this, we'll see how the components are inserted on the receiver. So most of the components are common in the receiver section also. The only thing is we have to insert this particular receiver, RF receiver. So as you can see, the antenna wire is here. So here also you will locate the antenna terminal. So here is the antenna terminal. So that has to be inserted near the antenna wire. And then we have an LCD here. So before that, we'll insert this potentiometer, which is used to arrange or change the display settings of the LCD. And then before inserting the LCD screen, we use a male birth strip. So this is a male birth strip, the connector base, and then a female birth strip is inserted onto the LCD here and then soldered, and then that has to be mounted on the LCD screen. So this is how the connections are done. And before inserting all the microcontrollers and the LCD, we need to check a power supply. So this is a digital multimeter with which we'll check the power supplies. And the black terminal is the common terminal which is connected to the body of the voltage regulator. So the third pin should show 5 volts, and the first pin should show the input power supply. The first pin of the microcontroller should show 5 volts. And as you can see, this is RX, TX, this is the VCC, this is the ground. So this is the third port is VCC. So I'll show you again how the connection has to be done. So as you can see, the TX is on top, so that has to be connected to the RX here, and then the RX, which has to be connected to the second terminal, which is TX, and then the ground is last, which has to be connected to the ground. So this is the ground, as you can see, and then the third terminal is the VCC, which is getting 5 volts. So that has to be connected to the 5 volt terminal here. As you can see, the 5 volt terminal has to be connected to the 5 volt terminal here. So once the power supplies are checked, you can insert the ICs and finish your kit. So this is how the kit is assembled. You can order this kit from our site kitsguru.com, where you'll get 2 versions of the kit. One is where you'll get the complete ready-made kit, and the other one is where you'll get a self-assembly kit, and with the help of our video tutorials you'll be able to complete the kit by yourself.